Hi there. Now in this question we're asked to find the area bounded by the tangent, the normal and the x-axis by the curve y equals x plus 1 multiplied with x minus 2 at the points where the curve intersects the x-axis. So if you'd like to have a go at this, just give you a moment to pause the video, and when you come back I'll give you the numerical answer first of all, and then I'll take you slowly through the work solution. Okay, welcome back then if you had a go. Well, I did say I'd give you the numerical solution first of all, and that is that the area is 27/16 square units. So, well done if you got that. Now I said I'll take you slowly through the work solution. Now to appreciate this problem, you've got to draw a sketch. I'd want to draw a sketch of this curve, and I know that it crosses the x-axis when y is 0, so that means that it will cross at x equals -1 and 2. That will make each of these factors 0. So we've got a parabola here. It's going to look then something like this. Now we've got to construct the tangents and normals at these 2 points. Okay. The question is, do we draw a tangent at -1 and a normal at 2? Or do we do a tangent at 2 and a normal at -1? Well, let's just say we start by drawing a tangent at -1. It's going to look, say, something like this. And then we draw the normal at 2. That's going to look like this. And so what we're looking for is the area contained in this triangle here. But suppose we did it the other way. Let's just put those axes back up and the graph where it intersects. This time, let's put the tangent at x equals 2. There we go. And the normal at x equals -1. And we're looking now for the area in this triangle here. But do you realize that they're exactly the same? Because of the symmetry of the graph, it would be right down this line here, okay? Then the gradient of the tangent, let's say at x equals -1, okay, it's negative, but it's going to have the same positive value over here. And the same applies to the normal. This is a negative gradient here for the normal, but over here it'll be the positive equivalent. So it doesn't matter which one of these graphs you work with. But to do the problem now, let's just say we work with this one here. I'll leave you to, say, try it again with this one if you didn't have a go. What I'm going to do then is differentiate the curve to get the general gradient at any point on the curve. Then I can work out what the equation of the tangent is and the normal at these 2 points where x equals -1 and 2. Then I'll solve them simultaneously to work out what this point of intersection is. And then when it comes to working out the area of the triangle, I'm just going to do half the base being this distance here, times the vertical height. So I'll need to look at the y value here. And that should get me the answer we need, 27/16. Okay? So let's start then by taking the curve. Okay? The curve then has equation y equals x plus 1 times x minus 2. And if we expand this, then we're going to get x squared, and then we'll have -2x plus x. Well, that's going to be minus x. And then you've got plus 1 times -2, which is -2. And then I can differentiate this to get the gradient at any point on the curve. So differentiating this would therefore have dy by dx equals 2x minus 1. Now I did say that I'll look at this graph here, okay, so if I just label that 1, okay, we'll just say for 1. But I definitely encourage you to have a go at this version, okay, for further practice. Now, if that's the case, I want to work out what the gradient is going to be at x equals minus 1 and x equals 2. So we'll just say then when x equals minus 1, what we've got is the gradient would be given by dy by dx, and that would equal 2 times minus 1, which would be minus 2, minus another one, that's going to be minus 3. And that checks out here. Look, we're going to have a negative gradient, quite steep as well. And when I look at when x equals 2, okay, the gradient there for the tangent, not the normal, remember, gradient for the tangent would be 2 by 2, 2 2's are 4, minus 1 is going to be 3. So therefore the gradient of the normal, okay, I'll put grad for short, grad of normal, well remember that's going to be the negative reciprocal of this gradient, so that's going to be minus 1/3. Now we're in a position to work out what the equation of the tangent would be. I'm going to use the form y minus y1 equals m bracket x minus x1. Okay, hopefully you're familiar with that form for the equation of a straight line. So we'll put here, therefore, equation, okay, of tangent, and we'll just say is, and what's it going to be? Well, it's going to be based then on y minus y1, we're taking 0 for the y coordinate here, equals the gradient. The gradient, remember, is minus 3, and then it's times x minus x1, and x1 is minus 1 there. Alright, so if I expand this, we've got y equals minus 3x, and then here we've got minus minus 1, so that's plus 1. Minus 3 times plus 1 is going to be minus 3. And I'm going to call that equation 1. I'm going to need to return back to this to solve simultaneously our equations for the tangent and the normal to find the point of intersection. So we'll just border this one off, okay, and carrying on, we're now looking at the equation of the normal. So I just introduce that. Equation of normal is, okay, now what's that going to be? Well, again, taking this point here now for my x1, y1 value, we're going to have y minus y1, which is 0, equals m, the gradient, which is minus 1/3, multiplied with x minus x1, so that's x minus 2, our x coordinate here. And what I'd want to do now is remove this 3 here, multiply both sides by 3. So therefore I get 3y, okay, equals, multiplying this by 3 just leaves me with minus 1 times x minus 2. So expanding that, I'm going to get minus x, and then minus 1 times minus 2 is plus 2. And I'll call this equation 2. And so we need to solve these two equations simultaneously then to get this point of intersection. So what I'm going to do is, let's say, substitute 1 directly into 2 because we've got y in terms of x here. Okay, so we'll just say sub 1 in equation 2. And what does that give me? Well, it gives me 3 times y, y being minus 3x minus 3, so minus 3x minus 3, and that equals minus x plus 2, minus x there plus 2. And if I expand the bracket, what have we got? We got minus 9x, and then 3 times minus 3 is minus 9, equals minus x plus 2. And I think what we'll do is let's add x to both sides. So minus 9x plus x is minus 8x. And if I add 9 to both sides, we get 2 plus 9, which is 11. And from this, if I divide both sides by minus 8, it follows that x equals minus 11 over 8. A quick look at this sketch here shows me that that's a good answer. It's less than -1, so it's going to be to the left of -1. What I need to do now is get the y coordinate though, so I need to just substitute this into, say, equation 1. So just say here sub in 1, and doing that we end up with y equals minus 3, then multiplied with x, x being minus 11/8, and then we've got minus 3. And if you work this out, we've got plus 33 over 8 minus 3 whole ones, that's minus 24/8, and so that's going to come out at 9/8. So 9/8. Okay, so that puts us in a good position now to get the area of this triangle here. So we'll just introduce this, say therefore area of triangle equals, and it's going to be half the base times the height. So the base is going from -1 to 2, so that length there is going to be 3 units, so it's a half times 3, and then it's multiplied by the height, and the height would be the y coordinate at this point of intersection, which we worked out is 9/8. So just put that as 9 over 8. And what do we have? We have 1 times 3 times 9, which is 27, and we have 2 times 8, which is 16. And not forgetting the units here, I'm going to write square units because it's an area. Okay, that brings us now to the end of this particular video, and thanks for listening, and I hope you found it of some value.